Jessica, so we are now on the second page of the notes. We have collected data on we flipped 2 more times, and that's the total results for all 4 of our coin flips that we've gotten. And then the corresponding graph that went along with it. Okay, once you've got your dot plot ready, let's look at question number 7. Give me a yes or no for this, and I'm going to talk through it. Does this dot plot resemble the first one?
No.
Just give me a yes or no. Or maybe like draw like one of these, like maybe a little, maybe kinda, and then I want to verbally chat with you about your answer. So tell me what your answer was, yes, no, or kinda. And then tell me why you say yes, no, or kinda. So, who wants to tell me?
I guess a little bit.
Morgan, go, I love it. I guess a little bit. Tell me how.
Because there's data from the last ones that's in there, but there's also new things.
Okay, so in other words, you know what would be kind of fun would be to kind of tease out which the old data combined with the new data, where it ended up falling. That would be kind of fun, actually. It would be a little bit misleading, kind of, because it would be heavy on this side, but I like that answer. That's good. I'm going to refer to something called the shape of data. Shape of data. Now, this is a new phrase. This is new. We're going to learn this right now. When you're looking at charts and graphs, statisticians often talk about the shape that a graph has. For example, a graph that we just looked at in 105 last week, end of last week, looked kind of like this. It was the same kind of plot, just like this, like a dot plot. And it had a bunch of bars, and they all kind of did this. There were a couple that were a little bit taller than others, and maybe a couple were a little bit shorter. But really, pretty much all the bars were kind of the same height. They were a little bit wiggly at the top, because things like flipping coins and rolling dice aren't perfect. But we call that kind of rectangular. Kind of rectangular, because it pretty much all the bars were the same height all the way across. Because we called it a rectangle, for lack of a better term. What would you call that? If you had to give it a name, what would you call it? Like a triangle? Yeah? Does that look like the last one? Kinda? No. Does the last one look kind of triangular? Kinda, sorta. Now, Jenna says no because it doesn't come down to the bottom. Like this one, if you were to put a triangle on it, it's going to look something like this. Maybe like that. And the old one that we did looked more like this. It was 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 1, 2, 3, 4, 5, right? That was the old one. So that one looks maybe more like home plate in a baseball stadium, because it goes like that. But you see how it still has kind of a triangle on the top of it? In other words, it's not a rectangle, right? The bars aren't all the same height. What does it mean if one bar is taller than another bar? What does that tell you about the data? Say that again! One more time, a little louder. Oh, there you are. I couldn't even tell who would say that. It was so quiet. I knew it was this table. But say it again. I watch lips. Yes, it means that data point happens more than the other data points. More frequent occurrence. So in other words, what was the most frequently occurring data point in this experiment?
1 and 2.
Say that again. 1 and 2? Yeah, and which one actually was the most frequent? 2 by a little, but not by much, yeah? 2 by a little, but not by much. Does that make sense? Why does that make sense? But why does it make sense that 2 out of 4 would happen the most? You see what I asked? Let me ask it differently. That's what I was fishing for. I was fishing for that because we should usually half the time get heads. So we should usually half the time, which if we do it 4 times, we should get 2 heads out of 4 the most often. Now, we got some weirdness, which I love, by the way. I love the fact that 1 is right behind it. And as a matter of fact, Amber, you saw how close it was. If we moved yours back to where it would have been the other way. Super close. That's what we call random clumping. We'll get to that in 105. That's a whole different argument. But it's related, but it's a different argument. Any questions, comments, concerns right before we move on? These are good discussions we're having. Shape of data. Okay. Ready for this? Number 8. One more flip. One more flip of your coin. Did you already do it?
Yeah.
Okay, if you already did it, that's fine. One more flip. Yes. Did we lose a penny already?
Oh, no.
Totally kidding, brother. Totally kidding. Totally kidding. You need more of them. Okay, so now you yourself have flipped a coin 5 times, yes? 5 times. And you have a number of heads that you yourself got, yes? Yes. Yes? Maybe? Okay, good. I want you to write down that fraction in number 8. Something out of 5. You're something out of 5. You're all going to have 5 in the denominator, right? Because you all flipped it 5 times. The numerator is going to be how many times you got heads. So what is the smallest fraction someone could write down for this? 0 out of 5. What is the largest?
5 out of 5.
Does anybody get 5 out of 5?
I got 4 out of 5.
Oh, we lost all of our... We had a bunch of 4 out of 4s last time, but y'all flipped tails this time, I guess. That's okay. It's coin flipping. It happens. Cool? Next, number 9. I want you to write whatever your fraction is, but I want you to write it with a denominator of 10.
Times 2.
Okay, if I have to. Barely awake here, man. Amelia, go!
Oh, I have a question.
Oh, you have a question. Please ask.
Did I do this right? Because you said that, like, I don't know if I explained it.
Oh, it's a little bit of sport. I love that. I love that. I love that. Thank you. You keep that right there. I want to. Yeah. That was a lot of sentences I just started. Didn't finish any of them.
Yeah.
Hopefully it made sense.
I'm gonna say it does.
Okay. Thank you.
Go ahead. We can say it. Just to be
Oh, this one.
Have you seen this before?
Remember, this
Oh.
is the second.
Yes. Got you. You know who invented this, right?
Not you.
It's me. It's my gift to you. I can't believe you said not you.
She tried to.
Well, it's a pie chart. It's been around for over 100 years.
Yeah. What was your fraction though? How many out of 5? 4 out of 5?
Yeah.
How many pie charts that you know can do that? And change colors on the fly?
Well, I didn't
Mine.
know it did that.
Well, now you
from
do.
Off of my base assumption with
It's
the
all
data
good.
I had.
It's all good. I love that answer, by the way. Okay, friends. What I want to do right now is stop you before you keep flipping, because you're going to keep flipping in a minute. We're going to collect some more data. What I want to do now is I want you to tell me your fraction out of 5. Matthias, I'm looking right at you. What's your how many out of 5? 1 out of 5. I'm going to change this fraction up here to 1 out of 5. So just so you know, this thing I'm using right now, most students will never use this. This is a little Excel thing I created that shows you equivalent fractions. So this is Matthias's 1 out of 5. Can you see why it's 1 out of 5?
Yeah.
Okay. You did good. Matthias, what is an equivalent fraction out of 10?
210.
Tell me why that's equivalent.
Because it's half of 1 bit.
Oh, I love that answer. So you made this out of 10, you called it 2 out of 10, yes?
Correct.
All right, hang on one second. Let me make this bigger like the other one so it's the same size. Is that the same size as this one? Yes. So I love what you just said. It's half. We cut all the fifth. Oh, it's actually exactly. If they're not lined up perfectly, don't worry about that. If you think about what happens when you break a whole into 10 pieces versus 5 pieces, what does that tell you about each of the 10 pieces? How big are they compared to the 5 pieces? They're each half as big. So when I break it into 10, you see how there's twice as many pieces here as there were over here. So now 1 out of 5 occupies the same space as 2 out of 10. Said without visuals, can you tell me how you can go from 1/5 to 2/10 mathematically? Yes, use method 1. Kind of, right?
No, totally.
I go with that. Totally. Yes. And then from the 80s, I love that word. Totally. Yes. 1 out of 5. 1 times 2 is 2. 5 times 2 is 10. Boom.
Exactly.
I love it. Thank you, John. I'm going with the total. I like it. Perfect. Make sense, friends? Okay, good. Good. Any other comments? So, Amelia, yes, what you just said, 100%. Now, ready for some more data? No? Nobody's ready for more data? Or are you tired? You already have? Well, if you haven't, do number 11, please. Flip 5 more times, and please, in total, you'll now have 10 flips. Keep track of how many heads, again, out of 10.
What did you get, Larry?
I got 8 out of 10.
That's totally fine. What we're gonna do is we're gonna, is that camera still running over there, Larry?
I got 6.
It's still red?
Yeah.
Okay, good. As long as we can see it. All right, back to our notes. There they are. Can I fit this? Yes, I can.
Keep losing track.
Wait, write it down. Right, remember what I told you? Write it down, write it down.
Did Brandon actually take the call? When I get back to the building, so I don't.
No, I shouldn't have erased that, actually.
Well, he's gonna give us math homework. I'll probably do it my own because it's not hard. I think it's literally, I just like take information and then I have to type it out.
I'm still waiting. No, my essay is due next week as well. Because he hasn't told us anything. Yeah, he assigns us a project freaking rating.
We have to take reading and then I have to take 4 ideas that I think are interesting and then write about them, but I have to read 2 chapters, so I have to do that.
I feel sorry for you.
I'm pumped. Not gonna lie to you.
Because
Where's my coffee? It's over there.
ready.
I do. Coffee's like the little, and the oat is like the slow burn. It's like the fuel injection. That's like the unleaded.
Wow. What?
Don't worry, it all makes sense.
I spaced out
You got it, you got
this
it.
injection.
It's okay, don't worry. Do you have your numbers?
Yes.
Let's collect them. Did anybody get no heads out of their 10 flips? I wasn't expecting it. Anybody get 1 out of 10? This is very special. We have 2 that got 1 out. Is it okay if I do that? 2 tallies? That's not 11, that's 2. Okay, good. 2 out of 10. How many of you got 2 heads out of 10? We got 1 more of them. We got 2. We got 2 of those. 3 out of 10. 1, 2. Yes. 4 out of 10. 4 heads out of 10. None. 5 heads out of 10. 1, 2, 10. Is it okay to just leave things blank when there's nobody in them? Is that fair?
Yeah.
Should I write something like a cross, or is it okay to leave them blank?
You okay?
I think blank's good, right? Because I think if I put a cross in, it might make us think something's there.
It's gonna confuse us.
I think so too. It's what confused me. More importantly, not more importantly, less importantly. 6 out of 10. 1, 2, 3, 4. 7 out of 10. 1. 8 out of 10. 9 out of 10. 1, 2, 3, 4. 18, 20, 24, 26. Let me count that again. Hang on. 6, 16, 20,
You have 24 up there.
4. So there's 1 more. We have no 9 out of 10? No 10 out of 10?
We have another 2 out of 10.
Oh, he's not here. Oh, I feel much better now. There, we have 1 more 2 out of 10. He's out of the room. Huh. Okay, I'm happy. Happy again. Never not really happy in math class, not gonna lie to you.
You should.
Okay, we go with this? You know what to do next. What are you gonna do next?
Plot it.
Yes! Dot plot! Do it! Do it. Come on! We got to go! Do it!
No, thank you.
Get to the job. Get to the chopper!
My psych teacher used to do that to us all the time.
What's that?
My psych teacher used to do that for me.
Who's your psych teacher?
Mr. He
Oh, not here.
Not here.
Not here, got
In
it.
high school.
Should I stop doing it then?
Yes.
Okay. Okay.
Terminator
Are we doing
belongs
that
in the
dot
80s. Leave it there.
We are, right there. Do your dot plot. Did you notice the little labels I put? These types of fractions are ratios, not rates. What's different between the ratio and the rate? I didn't use the words. The ratio is just the number, right?
I can feel your frustration.
Did I do that to confuse you? No. Why did I leave the words off? Why did I leave the words off, Jenna?
I have a question.
Oh, question, go ahead.
So on number 12,
Yes.
I'm not going to answer that.
Hold that thought. Hold that thought. We'll get to number 12 in a second. We're almost there. We'll get to number 12 in a second. We're almost finished. My question right now is why did I use ratios this time without words instead of rates with words? Any ideas? Because one time, I think that was a sneeze.
That was really on.
That was a yawn. It goes ahead anyway.
Thank you.
Why not put the words in there? The number one answer is because you're already familiar. We've done this experiment 3 times now. There's really no reason to have the words every single time. And number 2, look at that dot plot. How hard would that be to read if we had all those words shoved? There's 11 different numbers, right? 0 out of 10 up to 10 out of 10. If I shoved all 0 heads out of 10 flips, 1 head out of 10 flips, 2 heads, it would be crunched up and the font would be tiny, it'd be hard to read. So because of the familiarity, there's no need to have the words. And more importantly, not more importantly, slightly less importantly, it just makes the graph look better. Now, if you notice, I'm going to need you to remind me of these numbers because I'm going to lose them. I'm going to erase them and move the plot up, okay? When I slide this up, notice how I haven't left my audience completely hanging. It's got a label, fraction of heads gotten, right? So in other words, if somebody understands what a fraction is or a ratio, they can read that and know exactly what it's going to be. But it's clearer this way. Okay, good. How many 0 out of 10s were there? None. 1 out of 10. 2. 2 out of 10. There were 3 2s? Yes. 3 out of 10s? 2. 4 out of 10s? 1. 0. Oh, 0. None. Got it. 5. 10. 6 out of 10. 4. 7 out of 10. 8 out of 10. 9 out of 10. And no 10 out of 10s, right? Okay, good. We'll take a stab at the shape of this one. I didn't ask you this on your notes, right? What the shape of this was, but how would you describe the shape of this? Still triangular? Yeah. I think that's it. There's not going to be one right answer for this, FYI. I still think there's definitely a triangle with a peak. There's a peak in the data, isn't there? Where's the peak?
50%.
Yes, right where it kind of should be. Yeah, we should have a peak near the middle of the axis, right? I'm using a lot of quotes in the air like an annoying person. Yes, because the same 50-50 is applying to our coin flips, whether it's 2 or 4 or 5 or 10 or 20 or 30. So yeah, I still think it's somewhat triangular. Now some of you are going to say, yeah, but really what there really is, you can really micromanage it too. And if you wanted to, not you have to do this, you can micromanage it and say, oh, but look, there's like 2 groups of data. There's a group of data that's here that has a little microsplay, and then there's this little triangle over here. And you can totally say that if you wanted to. I have no problem with saying either of those things. If that's confusing, you don't look at it, just let it go. But the thing about it is there's different ways to describe data. But I think the triangle is the most obvious one, especially in light of what we've already seen with our previous data. This kind of plays into that. What would you think if we kept flipping coins over and over and over again? Do you think the overriding, go ahead. The 50% is still going to be that spike, most likely, unless the coins are broken in some way. And you're going to see kind of this, I would imagine. The middle's the highest, and it starts kind of tailing off. Do you think we'll eventually get somebody that flips all 10 heads out of 10? Eventually? Never? Okay, this is going to be fun. I'm going to make a program to flip coins for us in Excel. We're going to take a look. I'll do it over the week. take a look at number, I'm gonna write myself a note, because I want to. Take a look at number 12. It says, how close are your answers from number 8 and number 11? So look at number 11. Number 11 is your fraction out of 10, your 5 out of 10. Number 8 is your something out of 5, 2 out of 5. Look at those two numbers and tell me how close they are. And how can you measure closeness of fractions that don't have the same denominator?
Simplify it or just divide it?
What times by 2?
I'm hearing lots of things. Give it a shot. Jenny, go ahead.
This is right here because.
Oh, yeah.
So it's.
1 out of 5 and 1 out of 10.
10, so how do I?
How close are they? Hey, check this out. Our son is 5 feet tall. I can't believe that he's 12. It's ridiculous. I'm 6 feet tall. How close are we in height? A foot. How'd you get that 1 foot? How'd you get that 1 foot? You got it right. We're 1 foot different. You add a foot to him to get to me, or take my height, subtract his, what's left is the difference. Remember when I asked how different? That word is mathematical. Different. Subtract.
But how would I subtract 1 by 1? That's just.
It's not 1 by 1, it's 1/5 and 1/10. Shit. Change 1/5 to something out of 10. We're gonna do it in a second. We're gonna do it in a second. I promise you, my friend. I promise you. Don't you worry. That brain is working just fine, girl. You got this. You got this. Yes.
Did I do that right?
I don't know. So you got 4/5 and 8/10. How different are they? Oh, you changed that to that. Oh, yours was 4/5 and is 8/10.
Yeah, I got both.
I would say.
Not different at all. It's the same fraction, isn't it?
Yeah.
Beautiful. I guarantee you most people are not gonna have the same fraction.
I got that.
You got the same thing too, Zach? Okay.
I have
Let's go to Zach. Jack? Who do you have,
I
Zach?
get that all.
I got Zach at 98. He sits back there where Darcy is.
I have 4/5 and
Ah! I'm gonna give you the answer. Ready for this? By 1/10. Tell me why. What? Oh, this not gonna work for you. You probably have different numbers.
Yeah, no,
Okay.
I got super easy.
All good. Oh, you super easy. That's okay.
What do I
What about
write?
1 over 5 and 5 over 10?
How different are
What do
they?
I write?
Pretty different.
How different? You said 1 over 5 and 5 out of 10, right? Tell me how different. How much bigger is one than the other?
Nothing goes in the
Rate them so they both have the same denominator. So what's 3/5 with a denominator of 10? Oh, 6/10. Because if you change the 5 to 10, it's times 2. You also change the top 3 times 2 is 6, so it's 6/10 and 6/10. So actually, they're the same. 6/10 and 6/10, they're both the same.
I was able to.
We're gonna take a look at that in a second. We're gonna take a look at that in a second, I promise.
Then you times it by 3.
Okay, friends. I think maybe this number 12 is throwing us for a little bit of a loop. We're gonna figure it out right now. It's okay, it's okay. Yes, I like that too. I'm gonna fire up that little fraction equivalent thing over here. We're gonna take a peek. Like a Band-Aid, just get it over with. Okay. In case you want to know where this fraction thing is, it's in the same place on the website that little notes are. It's right here, Excel spreadsheet to help visualize fraction. Okay, who wants to give me their two fractions? Please.
1 over 5.
Okay, the first one is 1/5. 1/5. I'm going to hit Control Shift, boom. Okay, other one?
5 and 10.
5 and 10. Badoom, badoom, badoom. Okay, so now let's take a look. Here's the starting fraction of 1/5. Please notice we have shaded one of the 5 slices. That's 1/5. Here is 5/10. Please notice we have shaded 5 of the 10 slices. Now, without doing math, by simply looking at the picture, which fraction is bigger? When I say bigger, I mean which circle has more shaded?
The second one.
The second one, yeah? It's got more of the... a circle in a fraction like this. Does anybody know a fully shaded circle, what numerical value that has?
100%.
Say that again. Don't use percents though.
I'm sorry.
Oh, don't be sorry. I just don't want to confuse. I want to just use non. What's the whole circle shaded mean? What number?
1.
Say it again.
1.
A little bit louder and together. 1, 2, 3. 1, 2, 3.
1.
It's getting worse, so stop. That's 1. So if you start backing away from 1, they're getting smaller. The more you back away from 1, the smaller. Does that make sense? So clearly, this is more shade than that. So my question is, how much more? How much more? We have a vote for 3/10 more. Let's take a look. Let's take a look. Take a look back and forth. Do you see how this corner right here is sitting in the same place of these two right here? Is that fair? Does that make sense? I think it kind of does. Why don't we change this fraction so it's out of 10? What's 1/5 with a denominator of 10?
2 tenths.
2/10. So if we change this to 2/10, watch this. If I press this, is anything differently shaded than it was with 1/5? No, it's still the same shade. When I look over here, you see how I got 3 extra pieces here? That's how you can compare fractions. Very straightforwardly, put your fractions next to each other. This was 1/5 and 5/10. And just make sure they both have the same denominator. That way you're comparing them apples to apples. So 1/5 is 2/10. This is 5/10. So if this one here has 5 of those, and this one here has 2 of those, how many more does this one have? Don't forget that they're fractions. This has 5 of them. This has 2 of them. How many more does this have? 3. The thing that goofs people up with fractions is they overanalyze what the denominator is. Once you have the same denominator, you can just compare things apples to apples. If one's 5 and one's 2, that means the other one has 3 more. Is that fair?
You just do constant.
That's what we just did! Yes!
Well, but you did it in like
A conversational way.
well, I guess in a pie chart.
Yes! Or a pie-chartical way. Yes. Or a conversation. Yes, Morgan, you can totally use common denominators. Let me hear another set of fractions that we got. 3/5 and 6/10. 3/5 and 6/10. Watch, my friends. 3/5, 3/5, and 6/10. Ready?
Yeah.
Somebody just said it.
It's the same.
It's the same! Because if you change 3/5 so it has a denominator of 10, it's going to have 6/10, which is the same as 6/10, so they're the same! Which means you got exactly the same results when you did it twice as many times. Just making sense?
Yeah.
Give you one more? One more? Oh, are we feeling this? Are we feeling this okay? To make it, is it, you can kind of see in the connection to the math you've learned before? Yeah, I'm using pie charts for sure. Pie charts are a nice visual because you can actually see which ones are bigger before you do the math. But they're the same thing as find a common denominator. It's exactly the same thing. It's always out of 1, and it's some fraction of that 1. It's okay? And then once you know that, you can do the very last question, which is write equivalent fractions to the one you have in 11, which is the 1 out of 10, that has denominators of 20, 30, and 50. That's a quick little practice. Morgan, it's like your common denominators again, really. I just asked you to change your denominators to something else. How we feeling? Feeling okay?
Yeah.
Ready? We're going to do our lab next time. The lab is going to use this and apply it. Yay! To prep for that. What did I do?
Are you here?
I'm handing out homework. Yes.
Just making sure.
Yes, I am. Now the homework, I apologize, is 2 pages.
You did
I
Yeah.
couldn't fit it on 1. I'm sorry. So you might want to staple this puppy dog. Yeah? I did. It's front, back, and then a little bit of the next.
Is this D&D?
It's related. Not exactly the same, but related.
Is
Yes.
this D&D?
I think D&D dice. I think the 20-sided dice are D&D.
They're
Yeah.
all D&D. with you guys, but I'm sick
Oh,
of
really?
sitting-
I've never played Dungeons and Dragons, and I really want to now that I've watched Stranger Things.
I liked it before that show came out.
I know, you're old school,
My
you're
friend
OG.
Charlie loves that game.
I'm a total bandwagon hopper. I have 2 pages of homework, my friend.
I'm like,
Keep those notes, right?
and stuff,
Those notes are for you to keep, you don't turn those in,
and it's like,
okay? 2 pages of homework, it's a lot, it's kind of reading and picturing. So then it's got a picture of a guy from Jurassic Park on it, so.
it's all the podcast.
I did.
Playing D&D.
Oh, I saw you had this earlier, Connor. Came in.
Like, I haven't found
I
any
told him.
campaign.
Right.
I need a campaign. I have.
Okay.
I moved here, and like I moved from an area that no one played D&D, so I was
I'm gonna try not to yell so much,
and it's hard to
but
level
I
up.
know what you're getting.
Yeah, my friend,
Yes, we will.
him and his friends are making a podcast where we just talk about D&D, and they have like the whole studio made up house, like that's adorable.
You know what? Like, send me their podcast.
I will, like, get it. Because I'm pretty sure there's something, but you know, I don't know what else.
You can be mad.
D&D campaigns, all good stuff.
I'm sure there's gonna be a lot of shit windows, but
That's fun. No,
Thank you.
one of my friends.
Have a brilliant weekend. Make sure you do your journal before 10 a.m. tomorrow. Email me if you get stuck with anything. I'm around. Jessica, we'll talk to you soon.
it's like, I don't know.
I